In the past two videos, we've designed and implemented a class that represents a cell phone customer with a data usage plan. That class is now fully functional, or at least as functional as beginners need it to be. But there's one topic we kind of glossed over, and learning more about it can really simplify working with classes. That topic is constructors. I'm starting here with the code we created in the previous video, but I've changed the class name from cell customer to mobile customer with a similar change to the demo class. I store all these examples in a GitHub repository that I want to be easy for beginners to use, and I wanted to keep this version separate, so I wanted a different name, but that's the only change I've made. You can keep yours the same or rename it, or you can download a fresh copy from the repository link in the description. If you haven't watched those two previous videos, you should probably do that before we dive in and add constructors to our class. Let's start out in our driver class, mobile customer demo or cell customer demo. When we create an object, the assignment statement includes the new keyword, then mobile customer with parentheses. And again, if you're using cell customer still, it would be cell customer with parentheses. That has to be a method call because we know that parentheses usually indicate a method. But it's odd that it has the same name as our class, and it's also odd that we never wrote that method. So where did it come from? This is a special kind of method called a constructor, and it runs whenever an object is created. Its job is to initialize the object's data so that every field has a value. If the compiler doesn't find a constructor in the class at compile time, it adds a default constructor that initializes all the fields to their default values. So when we first instantiate our customer, the name and the phone number are empty strings, which is the default value for a string, and the two double fields are 0.0. After the object's made, we use the setters to assign the values we actually want. Instead of letting the compiler create a constructor that initializes our fields to default values, we can write our own constructor that assigns the values we actually want. Let's go over to the mobile customer class and give that a shot. A constructor goes right beneath the fields and above our regular methods, and its header is a little different than the methods we've made so far. A constructor is always public, otherwise it wouldn't be very useful. It's going to have the same name as the class, and it doesn't have any return type. It can have parameters, but we won't add any right now. And remember that if your class is still called cell customer, that's what your constructor should be called. The body of a constructor has one job, at least for now, and that's to make sure that each field gets assigned a value. So our pattern here is that we're going to have an assignment statement for each of our fields. We can assign whatever values we want, but whatever we put here is what every instance is going to get for their initial values. To test this, we can move back over to our driver class and comment out all of our calls to the setters. Now we can run this and see how it looks. Alright, so that's working well, but now both of our customer objects have the same data. So what we really want is to add parameters to our constructor so we can initialize each object with different values. Let's go back over to the object class and start on that change. Now we can have as many parameters as we want. We have 4 fields, so it would probably be a pretty safe bet to just make 4 parameters. But keep in mind that the data remaining field can be initialized to the same value as the monthly data field since they start out with a full set of data. So I really don't need to have a parameter for that one. And we can name the parameters however we want, but a common convention is to just give them the same name as our fields. So let's do that. In the body of the constructor, we'll assign the parameters instead of these literal values. As you watched me type that, hopefully there was a little alarm going off in the back of your head. When we learned about variable scope, I talked about how having 2 variables with the same name results in a conflict we call shadowing. This is causing shadowing within our constructor, but we do have a solution. I've been encouraging you to use the this keyword to refer to fields with that dot notation, this .name. When we do, the compiler can distinguish between the field and the parameter. So this .name equals name assigns the value of the parameter to the field. Be aware that putting name equals name compiles, but it doesn't work. It assigns the value of the parameter back to the parameter. Let's go ahead and update the rest of these assignment statements, remembering to assign the monthly data value to the remaining data field as well. Now, when we look back over at our driver class, we'll see that we suddenly have a problem. Our object creation statements don't compile anymore. Remember that the compiler will create a default constructor if we don't define a constructor ourselves. But if we do define a constructor, the compiler doesn't add the default. So now the only way we can create an object is by using the constructor that we wrote. Usually that's a good thing and that's what we want. So let's add some arguments to these two constructor calls so that they're valid. That should make it compile and run, so let's see what we get. Before we added a constructor, we had to set field values using our setter methods. There are a couple advantages to using a constructor instead. First, it's a lot easier to create an object and set it all at once. We can do it all in one line of code instead of calling each setter separately. Another advantage is that we can now think about our set methods a little differently. Instead of just making a setter for each field so that we can get values in, we can now evaluate whether we really need to change the value of a field after the object is created. If there's no need to change it, we don't need a setter for that field. Consider a class that keeps track of student information here at the college. One of those fields is a student ID number, and that is used to tie together all the records across the college. If that field is changed, it's likely to cause a lot of problems, break a lot of connections, so we probably shouldn't provide a setter for a field like that. Remember that encapsulation is all about minimizing how we expose data, so you can think of constructors as another tool to help with that. And there is another really nice advantage to adding constructors to our classes, and that's the ability to overload them. Remember that overloading is when we have two methods with the same name but a different set of parameters. We can use that concept with constructors, and it's a great way to provide flexibility when creating objects. Let's go back over to our object class and add a second constructor. This one will have parameters for the name and the phone number. Only the name and phone number fields will be assigned from the parameters, but we still need to put something in these two data fields. We'll set them to 8.0 since 8 gigabytes is going to be the standard plan that our company will offer. With that second constructor in place, we now have two options when we instantiate an object. We always have to provide the name and the phone number. We have to have that information in order to set up the account, so both constructors require those two things. But we can choose to specify the monthly data quota or leave that argument out, which means that the object will just get the default of 8.0. With overloading, we can provide as many different constructors as we want, which gives us a lot of flexibility in how we create our objects. That really covers the basics of constructors. They simplify object creation and they give us more control over encapsulation. And going forward, now you can decide how to best design your classes using setters and constructors together.